Okay, on digital circuit or port, TDM or FDM may be used. The TDM and FDM are the two methods of multiplexing multiple signals into a single carrier. Okay, what is multiplexing? Multiplexing is the process of combining multiple signals into one in such manner that each individual signal can be retrieved at the destination. Since multiple signals are occupying the channels, they need to share the resources in some manners. In TDM, a single facility is split into multiple time slots of equal size. Each pair of users is assigned a time slot when the circuit is established. That time slot remains dedicated to them for the life of the circuit. TDM are usually implemented as T or E lines and allow for multiple calls to place across simultaneously. Traditional PBX units use TDM for the transmission of voice and signal and interconnect with PSTN. On digital circuit or port, TDM use time slices for specific channel, and the communication channel take turn and communicate only during their assigned time slices. The time is divided between the needed channels in order to multiplex or combine multiple signals on a line. As stated previously, T1 line has 24 different slices or channels, assuming that full T1 line is purchased. What's the primary difference between FDM and TDM, between frequency domain multiplexing and time domain multiplexing? Well, frequency domain multiplexing divides the channel into two or more frequency ranges that do not overlap. On the other hand, time domain multiplexing divides and allocates certain time period to each channel in alternating manners. Due to the fact that we can say for TDM, due to this fact, we can say that for TDM, its signal uses all the bandwidth some of the time, while FDM, its signal uses small portion of the bandwidth all the time. I can show you in this figure. Okay, you can see that the top one is a TDM is divided by time, and this is frequency. The FDM is divided by frequency. For example, the first one is for data, the second frequency is for voice, and the third one is for video. The pros and the cons. Well, TDM provides greater flexibility and efficiency by dynamically allocating more time period to the signal that need more of the bandwidth while reducing the time period to the signal that do not need it. Frequency domain multiplexing lacks of this type of flexibility, as it cannot dynamically change the width of the allocated frequency. TDM has replaced FDM. Packet switching is expected to be the de facto standard of the voice over IP. Traditional TDM uses assigned time slot for channel and assignment that do not change. Statistical TDM reserve time slot. Statistical TDM requests a time slot only when it is needed. Thus, therefore, statistical TDM can be oversubscribed. Okay, this is the last part of this chapter, digital circuit signaling. There are two types of digital circuit signaling. The first one is CCS, common channel signaling. It's a signaling that is sent over the different separate channel other than channel over which voice calls are carried. Common channel signaling has common channel used by signaling by all other channels. For example, with the ISDN connection, the D channel is for signaling, while the B channels used to send the voice. So they use separate channel. So there are only, for example, it's only 23 voice channel available for T1 line. Okay, CAS is channels associated signaling. In cache, signaling is sent over the same channel over which the voice are carried. For example, each channel use in this signaling method, each channel use 64 kilobit per second bandwidth. 8 kilobit is for signaling, and the other one is for voice transmission. Although 24 channels available, therefore in-band signaling may reduce quality. Okay. I reference this on page 347 here in more details. Okay. In cache there are 24 channels, 24 voice channel available, compared to this CCS. They only have 23 voice channel available because the other channel is used for signaling. So they separate it. Okay, they separate it. Let me see here. Also here it say in cache there are 64 kilobit voice bandwidth per channel, and then in CCS, whereas in CCS there are only 56 kilobits per second voice per channel. Let me see here. I'm gonna fix this a little bit. Uh, 56 kilobit per second voice bandwidth per channel. Bandwidth. This is kilobit. Here we go. Thank you.